So hi there, this is Ayush and welcome you to this 8th part of the masterclass series on ball screw linear actuator design. And today we will try to finally complete our ball screw linear actuator design in very optimistic way. We will address all the common problems we faces as a mechanical design engineer in order to align the LM guideway and the ball screw together to get the smooth operation. Also, we will learn how we can relax the manufacturing tolerance of ball screw linear actuator to cut down the manufacturing cost. Because maintaining a close manufacturing tolerance for a long linear actuator base plate like 1 meter is challenging. And top of that, we will learn how to design, or we can say where to design, a customized coupling, or we can say float joint for a ball screw in a linear actuator. And now we are in Solidworks, and these are our linear actuator components as far as we make the selection and design. If you come on this video directly, you can check out the complete playlist on ball screw linear actuator design. Link is in description. And now let's bring the LM guide and blocks. So go to the assembly, go to insert component and select LM rails and bring it into the assembly. And here I have downloaded the rail length 1420, and I have considered some extra length. Why? Because I was wanted the last hole of rail should be at the same distance from the sides, and this is the 20 mm, and also at this side this mounting hole is at the distance of 20 mm from this side. And the benefit will be we can mount this rail in both orientations, like this also or like this also, and this is just a very small advice. And now let's make a copy of it because we are going to use the two rails. And now let's bring the LM block right here, and now let's try to assemble this linear motion guide and block into this assembly. So we have to mount this rail with the base plate, and we have to mount this LM block with the sliding plate. So go to the mat and select the top face of the base plate and select the resting face of the LM guide and hit OK. Just position it. So just for temporarily I am just mating this and hit OK. Also do the same at this end. Also temporarily mate this, just one block, but there is a gap. And we cannot bring this sliding plate down because this sliding plate to be mounted with this ball screw nut, something like this. So there is a two option. The first option is we can bring the LM block down and assemble with this rail, and we can design a spacer here, something like this at the both side. And the second option is we can mount this LM guide at the top, and to do that we have to design a spacer below the LM guide. Another question is which option is better. So first let's try to understand it. So as the first option is, we will design a spacer right here above the block and mount the sliding plate with this block and mount this LM block with this spacer. So what is happening here, we are increasing the cantilever distance from the load, and it will apply a high amount of movement over this LM block that can reduce the life of the LM block. And now let's look at the second option. And the second option is we have to design a spacer below the LM guide. And when we will do that, the cantilever load will be minimum and it will apply the minimum movement over the LM guide block. So we will go with the second option. We will design a height spacer below the LM rail. So how to design a height adjustment spacer, or we can say height adjustment block for the linear motion guide. And there is finality of method to mount the LM rail with the base plate. You can check out the catalog for the more detail. But in general, we will design the height adjustment block something like this. We will maintain this resting height to the base plate very accurately, and we will give an edge here, something like this, so that we can mount this rail by butting it on this edge. So that we can accurately maintain the distance between both LM rails. I hope you get my point. Otherwise, if you will not use that kind of height adjustment block, maintaining a high accuracy parallelism between both linear motion guide will be difficult. Because LM guide not comes with dowel holes, it comes with clearance hole. And there is one more thing. So when we will design that kind of height adjusting spacer block, then we will need to mount this block with the base plate using the dowel pin. Otherwise, the distance between rails will be not accurately controlled. Or we can make the cut like this and we can place the height adjusting block with the edges. And these two methods are costly because the length of LM guide is more than a meter. And machining such kind of height adjustment block in a one part is difficult. However, we can divide this height adjusting plate into multiple parts. But again, the cost will not reduce. So now let's talk about the solution. And the solution is, instead of using these separate blocks, first we can weld two simple bar without machining over this base plate at the both sides. Something like this. There will be a welding. Also, we will do the welding on this side. And these blocks are just a raw block. There is no machining. We don't have to do any machining on this plate before the welding. And after the welding, we will place this welded structure over a machine, a milling machine or VMC machine. And then we can machine this edge in a one set of the machining. Oops. Makes sense? In this way, we don't have to use any dowel pin. We don't have to use any edge step here on the base plate. Also, we don't have to machine the every part individually. We just have to first welding these parts together and then machine the only resting part of the LM guide. So now let's try to make this base plate with this welded bars. So just open the base plate. And here, as we did these mounting holes in the previous part of the series, we don't have to do it before welding. Just for demonstration, I'm just suppressing this. Okay. And now go to the sketch, take the sketch and take the sketch on this plate. And now go to the rectangle tool, corner rectangle tool, and start from the top and end it at the bottom at the both sides. And now go to the smart dimension and set the width of this plate to 30 mm. Why? Because the LM width is 20 mm, so we can leave the edge width to the 10 mm or you can go for the 28. It's all up to you. And now just make them equal. And now there is a thing, we have to leave some space here so we can weld the edges from both sides. Also, we will make the mounting bolts on this base plate so we can mount this base plate or we can set this whole system on a structure. So now go to the smart dimension and set this gap to 30 mm. It's up to you, and again set it to 30 mm. Close the sketch, go to the feature, extruded boss, and set it to blind. For now, I am taking it to 60 mm. We will adjust it later, definitely. And here, just uncheck the result. Otherwise, it will seems like the whole part is manufactured from one raw material. So now, just hit OK and go to the weld mat and select weld bits. And here, just select the faces, or you can check the both sides. So you will get the welding on the both side. And here we can set the welding size. This is 5 mm, but I don't want continuous welding. I want intermediate welding. So check the intermediate welding, pull this bar down. And here we can set the welding length and the gaps. So I'm setting the welding length to 50 mm and setting the gap to 100 mm. Or you can increase the welding length. Go for 100 and hit OK. But the welding width are not showing. So go to the I button and check it. and click on view welding weight. And now the welding weights are showing. And now we have to repeat the same process on this side. But the welding symbols are looking crazy, so just double click on it, and here this is the welding size, this is fine, but here this is not a good representation, so just take it like 100-100. Also other side 100-100. 100 is the length of welding and 100 is the pitch of the welding. And you can also change the welding type. So this is fillet welding, this is okay for me, and hit OK. And now go back to the assembly. And now let's try to step cut here and mount this rail onto the cutting step. So let's open it and go to the sketch, select the sketch and select the face, go to the rectangle tool, corner rectangle tool, and start from this corner, and same start from this corner and just make them equal because it has to be equal. Also make the depth as equal, and here set the length to 20 mm. You can take it some extra also, it's up to you, and set the depth to 3 mm. We will check it and adjust it. Close the sketch, go to the feature, go to the extruded cut and set it to through all and hit OK. And now just for identification, I am just changing the color of these faces to red. So it will be a identification that this surface to be machined, and hit OK. And now we can make the mountings threaded hole for motor mounting block. So here I am just unsuppress it. And now let's back to the design. So now we have to mount this rail over this face. So let's first temporarily mate it. So go to the assembly, select the mate and select the faces, coincide this, also coincide this edge and also coincide these faces and hit OK. And now this rail is extra, so what we can do, we can increase the overall length of this base plate. So first let's measure it, and this is 37 mm. So just double click on it and click on the dimension and add 37 mm and rebuild it. And now there is a problem. The motor mounting plate has been shifted, and there is two problems. The first problem, we have not applied the mate in the mounting holes, and the second problem is the length of the ball screw. We have to extend the length by 37 mm. So first let's try to mate it properly. So I'm just selecting the part, go to the mate property, and here this mate is the motor mate. This is also for the motor. This is for the parallelity. So let's delete it. We will mount it with the holes. And this mate is for the bearing block. This is also for the bearing block. And this is the parallel mate. We can delete it and we will mate it with the mounting holes. And this is okay. This is also okay. Select the ball screw, go to the mate and check it. And this is the face where this is mate. So just temporarily suppress it. And now we can move it around. And now go to the mate and first mate this. Okay, and also mate this hole. We need to mate at least 2 holes. Hit OK. And when we mate this hole has been shifted. Why? Because this hole was made from external reference, and you can also see this symbol. This symbol is for external reference, and sometimes it might be a reason of making mistakes. So always try to make the holes with the external reference and then break the external reference and give them dimensions. So let's try to do it. So as we know, this hole is started from this face at distance of 15 mm. So what we will do, we will open the part and go to this sketch, select the sketch and edit the sketch. And now we can see these points are external reference. So first just delete the points. Okay. And now go to the smart dimension and first set the dimensions as it is. You don't have to change anything. And now go to the line and select center line and start from this center point and mate it with the center point. And now again go to the smart dimension and now set it to 15 mm. And now close the sketch. And now there was an arrow and now this is removed because there is no external reference. Go back to the assembly. And now this is perfectly fine. And now just try to move it. This will be not moved because this is completely constrained. And now we can also constrain these things. So go to the mat and select the holes. Hit OK. Again do the same. And now this part are completely constrained. And now we have to increase the length of ball screw. So just double click on it and select the dimension and plus 37 mm and just rebuild it. And now this is perfectly fine. And now we have to mount this rail over this plate. So just open it and go to a sketch. And if this is disturbing, you can just hide it. Right click on it and hide it. Okay. Now go to the sketch and select this face and go to the center line and start from middle because the width of this face is same as the width of LM rail. If it would be not, then I will start from giving the distance from this edge because we have to align the guide with this edge. And now we can set the distance of 20 mm. 20 mm is the distance of first hole of LM rail from one side and make this vertical. Go to the sketch, go to the feature, go to the hole wizard and the size of mounting hole of rail is 6 mm. Clearance hole diameter is 6 mm. It means we have to use M5 bolt. So go to the threaded hole and select the thread size M5 and pull this bar down and select it to blind and set the depth 20 mm and thread length 16 mm and go to the position 3D sketch and just mark the location and hit OK. And now just hide the sketch. Go to the linear pattern and select the pattern direction. I'm selecting this edge. Go to the feature and select the threaded hole. You have to only select one threaded hole because we made the both holes at the same time. And now we have to set the pitch of LM guide mounting holes, and the LM guide mounting holes generally comes with 60 mm of pitch. And now we can just increase the numbers of holes and this is OK and hit OK. Now just go back to the assembly. So select the part and go to the property and you can just delete the temporary element and just try to mate this with the mounting holes. So go to the mat and select clearance hole and the threaded hole and hit OK. And now we have to mate one more bolt and we can rest it properly. This is cool. And just repeat it at the other side also. And now let's try to mate this mounting block onto the rail. So go to the mat and select the face, top face and top face of the rail and one of the side face and mate it with the appropriate face and hit OK. And now just repeat the same process for the all blocks. And now we have to mount these blocks with this sliding plate. So first let's measure the mounting CD and the size of threaded hole. So the threaded hole size is M5 because the diameter is 5 mm. We can also check the catalog. And the center distance from one to other hole is 32 and this one is 36. And from one side this is approximately 20 and from this side, this end side to this end side, the distance is 188 mm. So let's open this part, go to the sketch, select the sketch, select this face, and first take the center rectangle tool and start from the origin. And now select the complete rectangle and convert it into construction line. And now go to the rectangle tool and select corner rectangle tool. Oops. And start from the corners. And now make the same center distance equals. Okay. And make these center distance horizontally equal. Go to the smart dimension and set this distance to 32 mm and set the vertical CD to 36 mm. And as we measured, the inner center distance of two blocks from hole to hole was 188 mm. So set it to 188 mm, and this side was 20 approximately. So here I am setting it to 25 mm. This is up to you. You can set it to 30 mm also. Now close the sketch, go to the feature, go to the hole wizard and select contour bore. Why? Because on the top of plate we will place our drilling system. So the bolt should not be on the face of this plate. So here select the socket head camp screw and select the size of M5 already selected and set it to through all. Go to the position, go to the 3D sketch and make the holes at all the corners at once. Hit OK. And now we can also add some chamfers just to give them a good aesthetic. And now just go back to the assembly and now we can mate this. So go to the mat and select the clearance hole and the block hole. And now have a look. This is completely fine. And here is a thing, if you assemble these blocks into the rails and accidentally if this block will fall, their balls can be missed. So what we can do, we can add some stoppers here. And to save the time, I have already designed this block. This is very simple. So just go to the insert component and bring the LM stopper block. And we can mount this block over this height adjustment block, something like this. I'm just temporarily mating it. You can take your time and make the thread on it and assemble it. And in the manufacturing, we have to make the threaded hole manually because we cannot make the holes of 1 meter long block vertically. Okay, and this is quite simple, the making the hole manually in that condition. And this stopper is not for stopping the movement. Okay, this is not for stopping the movement. This is only for preventing the blocks to coming out from the rail during the assembly, because we will stop the slider with ball screw and the servo motor. So now we have to just replicate this at the all 4 corners. And there is one more thing. To ensure that LM rail will always align with this step, we can add the rail locking plate. Let's see how. So let's bring the locking plate. I have downloaded it. It comes in a standard size also, or you can manufacture it as well. So just open it and bring it into the assembly. And now just rotate it. And I'm temporarily mating this. Oops. Okay. Something like this. So what we will do, we will make the threaded hole over this plate and we will tighten this locking plate with the bolts. Something like this. So when we will tighten this bolt, because there is a cut, so let me take it to normal view and just hide it for this instance. And when we'll tighten the bolt, this block will start pushing this LM rail, and it will be ensure this rail will be always aligned with this step. I hope you get my point. And you can assemble this at the gap of 300 or 400. I'm leaving this up to you. And now I want your closer attention. As I said that we will take the raw material pieces and then weld them together, and after that we will machine this step for the LM guide, and we can maintain these faces and we can maintain this level at one set of machining, and also we can maintain the close tolerance between these steps. This is totally fine, but there is a problem. Because this plate is a raw material plate with the rough grinding finish, we also have to machine these faces because our bearing arrangement are mounted on these faces. So we also have to maintain the close tolerance between ball screw center line and these faces, this face height, and the distance from this LM block, this distance from LM rail to the center distance of the ball screw. So how we can do that? So we have to machining the resting face. So there is two options. Either we can machine the complete plate throughout the length, or simply we can only machining the bearing mounting or bearing resting face, like here and also like here, something like this. We don't have to machine all over the faces. So let's try to do it. If you are a beginner, or might be you are a student and you are following my design from starting, you might be get angry on me that why not I start the designing with the welded structure, why I first design the simple plate and at the end I change the design. And I am completely agree with you, because I was already know start to end. When I was recording the things, the final design was on the thumbnail of the first video, means I record the total 10 parts at the once. But there is a thing, I'm not making this kind of video just to give the information to you, just to transfer the experience to you. It is not like that only. I'm making the videos in such a way that you can feel the problems. You can feel the problems at every steps. You will start with a very obvious thing. And I want you to start with the very obvious thing. You don't have to think a lot when you are starting. Just start with a very obvious thing and go step by step. And at every step, feel the problem, analyze the problem, and then correct it. And this is how we design our complex machines. We start with very obvious things, very simple concept. And then we start adding the things. And at the same time, we making the corrections. But when I will start the design like an expert, I will try to understand you everything, every steps, every problem in one video. You will get confused. You will be not get and learn that I want you to understand. This is not just a knowledge. This is the experience that I want to share with you as it is. और जो भी मैं एक्सपीरियंस से सीखा हूँ वो सब एक ही वीडियो के अंदर बता दूँ तो इट मैंट बी पॉसिबल, बट आप उस चीज़ को फील ही नहीं कर पाओगे. Because I learned from many mistakes. Okay, as a beginner, I did many mistakes. At the manufacturing level, I mixed the design and they manufactured, and we faces many problems during the assembly, during the trials, and I never forget my mistakes. So I truly believe when you do some mistakes and you acknowledge the mistakes and you start thinking about the mistake, to how to correct it, what I can do so I will not make the same mistake again and again. Because चाहे कुछ भी हो जाए, आप कहीं पे भी काम करो, कोई आपसे ये चीज़ छीन नहीं पाएगा कि आपको डिज़ाइन करने आता है, आपको प्रॉब्लम समझ में आता है और आपको उसे करेक्ट करने भी आता है. And these things make you a perfect designer. And also, I'm not saying there is only one way to design the things. There is an infinite way, infinite possibility to design a thing. It's depend on how you want to design. Do you want to save the cost? Do you want to increase the performance? Do you want to make the machine for easy maintenance? Do you want to make the machine for low consume energy? Do you want to make your machine to aesthetically stand out? Because design is not a software. Okay, in a software there is a limited way to do something, but in a design there is infinite way to achieve something. So let's back to the design. So just select the part and edit the part. Go to the sketch, select the sketch, select this face and select the rectangle tool and roughly draw it something like this. Also at that side something like this. Just close the sketch and open it. Go to the sketch and edit the sketch, and here select a center line. Select this face center line and select this point and make them center and set the distance to 155 mm. This is up to you. Also you can set it to 150 mm. This is also up to you. And here what I will do, I will just align the lines, make collinear. Also this side, make them collinear. This is not necessary, I'm just doing it for look symmetrical. And we can set this dimension to 50 mm, but this is not in center. So what we can do, just for now place it at the side and take a center line and just start from the origin, and now just bring it right here and select the point, select this point, this line, and make them make into the middle. And now this is completely fine. Close the sketch, go to the feature, go to the extruded cut. Oops. First select the sketch, then go to the extruded cut. So it will be automatically select the area. And here I'm taking it to 2 mm. It's up to you. You can go for the 3 mm also and hit OK. And now we can add some fillet here. Something like this. Also at this side. But there is no threaded hole. So we have to add the threaded hole for the float bearing also. Now just hit OK and go back to the assembly. And now just try to add the threaded hole here. So just measure the clearance hole size. This is 11 mm. So there will be M10 bolt size. And the center distance is 85 mm. And from side this is 15 mm. So just open it. Go to the sketch. Take the sketch right here and go to the center line. Start from center. Go for both sides and make them equal. Go to the smart dimension and set it 85. Also set this dimension to 15 mm. Close the sketch, go to the feature, go to the hole wizard, go to the threaded hole, select the threaded hole to M10, and now go to the position and mark the hole positions and hit OK. Hide the sketch. Go back to the assembly, and now we can just make these holes. Okay. Now as we made these bearing blocks with this surface, now we have to change the mate with this first surface. So how to do that? Select the part, go to the property manager and try to find out that mate and edit the feature, and you just have to delete the face and select the new face, but it will give an error because the first bearing block, the fixed bearing block, is mated with this face, the top face, and the ball screw is connecting these bearing blocks. So just don't worry and add this mate and hit OK. And select this bearing block, bearing mounting block, go to the mate and select that mate, and you can change it here. So just select it, delete it and select this face and hit OK. Now error has been gone. Okay, now let's move to the second step. And now our next step is to assemble the sliding plate with the ball screw. And to assemble this, the first option we have is very simple. We can design a block something like this, and we can simply mount this block with the ball screw nut, something like this, and we can mount this block with the sliding plate, something like this, with the 4 screws. So when the motor will start rotating, the screw will start rotating, and the screw rotational motion will convert it into the linear motion because of nut screw mechanism. But there is a thing, we have to maintain the perfect alignment of this ball screw center line with these 2 guides. And the ball screw alignment is controlling by the motor mounting block and this support bearing block. So we have to ensure that these bearing blocks are perfectly in between these rails. And in order to do that, we have to maintain a close tolerance relation between this bearing block mounting and the rail mounting structures. And if the ball screw would be like a precise type, this is the rolled ball screw, then we have to maintain more close tolerances and the manufacturing cost can be higher. So in order to overcome from this problem, we can design a coupling here, but there is also drawback of this coupling that we will discuss later. But let's first understand how we can design it. So at the very first, we will take the same block, same simple block, and then we can add the pins on the both side, and we can assemble this with the ball screw nut, something like this. And after that, we can attach this type of machined plate with this sliding plate. So let's see what is happening here. So I'm taking a cross section. And now this ball screw nut is not directly connected with the sliding plate. This is connecting through a mechanism, and in this mechanism we are giving a space to the ball screw system that ball screw can be moved. Ball screw nut can be moved in lateral space. So if our ball screw bearing arrangements will not make perfect alignment with the LM rails, there is no problem. We are giving a tolerance, a relaxing tolerance. And in the vertical direction, here I am not giving any clearance. This pin is perfectly into this slot at the both sides. But if you want give also relaxation in the vertical direction, you can give a clearance here. So just double click on it, and let's say we want to give a 1 mm of clearance. So just minus it by the 1 mm and rebuild it. So there is a clearance, means our ball screw and our rail mounting height adjustment block have a relaxation in maintaining a close tolerance. But there is a drawback, and the drawback is the backlash. If you will give a clearance here, this will add a backlash value, because first the ball screw nut will rotate by the some angle, and then this will touch this plate, and then the sliding plate will start moving. I hope you get my point. But in the vertical condition, where our sliding plate will be always overloaded, always preloaded, this backlash will be eliminated. But in the vertical condition, there might be a problem. So in that case, where backlash is not too much important, then you can apply this method. And here I show you that what is the advantage and what is the disadvantage. You can use this kind of coupling just to relax the manufacturing tolerance and save your cost. And the disadvantage is that will add some backlash. But if you are thinking something differently, please let me know in the comment. But there is a thing that I want you to know. If you are going to add pin something like this, you have to add the chamfers here. Otherwise the stress distribution will be not uniformed. And also if you don't want to add the pin, So what you can do, you can make a through hole here and then you can insert a pin here at the both sides, and then you can fix it with the curve screw, or we can say set screw. This is also fine. And there is one more advantage that I would like to explain you, making this transparent. And now let's suppose our drilling system is something like this, and this is attached with this plate, and the loading is being here, the force of action is being here. So this force of action is creating a movement on this sliding plate. And with the time, if this guide blocks becomes loose because of wear and tear, the load will start coming on the ball screw, and in that case the ball screw will also face the movement force, and this is not good news for the ball screw. Ball screw can be easily wear and tear if you connect the ball screw directly with the sliding plate. I hope you get my point. But if you are using this kind of arrangement, there is a benefit, because whatever the force will be on this plate, the force on the ball screw will only coming through this pin, and this pin is only touching at these 2 points, which is a line contact and which is in the center of the ball screw nut. So whatever there will be movement, there will be only a axial force on the pin, and this axial force only will transfer to the nut. So when you designing a ball screw system where your loading is far from the axis of ball screw, you have to have used this kind of arrangement. And now just change the transparency, and top of that we can add our arrangement, our drilling system. So just bring it the drilling system, select the drilling system, and we can mount this drilling system on this sliding plate. This is very super easy, there is no problem. We can mount this somewhere in the middle with this bolting. And now there is a thing, running our ball screw mechanism within the stroke, we have to use sensors. And what are the sensors? So the first sensor we should definitely add is the homing sensor. So the servo motor can initialize their position, their initial position. So this is the home sensor. And after that we should also add 2 stream sensor, streams position sensor. So whenever there will be any problem in the programming, so the system could not pass the stream positions, and this sensor will be act like a safety. And for these sensors we can either use the mechanical multi-position limit switch. If you want to confirm the position at the multiple distance, and to use it you will also need the rail dogs for the multiples limit switch, or you can use the simple limit switch. Also you can use the proximity sensor, and also you can use the sensors like this, the frog sensor. And for this application I have selected the fork type sensor. So go to the assembly and select fork sensor, and here I have already designed the mounting arrangement for the sensor, and the arrangement is I have designed a split type of block here. There is a threaded hole at one side of a split cut, and at other side there is a clearance hole. So when we insert this bar, rectangle bar into it where we mounted the fork sensor, and when we tighten the nut, this bar will get fixed into it. So let's temporarily mate it. We will mount it on this face here. I will also leave the design of this bracket into the description so you can study it later. And now we will mount a pin here, or we can say a dog here, which can sense this probe sensor when it will be passed through this beam. So let's see how. So just insert that dog component that I have designed right here, and now just try to mate it with this plate into middle. So when this will pass through the probe sensor, there is a curtain, there is a light curtain, and this will be get disturbed, and this will give the signal to the control system, and then we can either stop or start the servo motor and actuate it accordingly. And this is how the sensor works. But here there is a thing. We can adjust the height of the sensor easily. We will just lose the bolt and we will adjust the height, because we have to design a height adjustment mechanism for the sensor mounting, because there can be a manufacturing variation and there is no too much space. There is a space of 1 mm, and it's also depend on the type of the sensor, model of the sensor. So you have to consider adjustment blocks for the sensor. If you are using a sheet metal sensor brackets, then I would suggest you go for the 3 mm thicker or 5 mm thicker, because if you will go for the 1 mm or 2 mm, and whenever there will be a physical accident, your sensor bracket can be damaged, and in the result of sensor bracket damage, there can be a major accident. I hope you get my point. And now we can just replicate it at the 3 position. I am leaving this up to you. Also, for the wire routing, we can use the drag chains. So just let's bring the drag chain I have already designed and just assemble this, mount this with the plate. Something like this. This motor wire will be connected with this wire. Actually, this is the motor wire. So when this will make the motion, the wire will be not messed up. This is why we use the drag chains. These are the links of the chain, and it can bend something like this when there will be a movement. But I would also recommend, when you are using for the vertical system, use the drag chain tray. You can manufacture it also, or you can buy it as a standard product, because this makes your drag chain perfectly aligned. Congratulations, our linear actuator design has been completed. If you have any suggestion how we can further improve the design of this ball screw linear actuator, please let us know in the comment. And as I promised in the first part of this series that we will make the ball screw drawing, so let's do it in the next part of this series, and where we will try to understand the design intent, and we will try to make the drawing of the ball screw using GD&T. So thank you so much for the watching.